All right, 7-5, Pythagorean Theorem, day 1. We are going to spend the rest of this unit working with right triangles, and we're going to start with the Pythagorean Theorem. Okay, so when we have this little square in the corner, okay, looks like a right angle, has a little square in the corner, and we know that that little square means that this angle measures 90 degrees. All right, anytime you see that little square, it's a right angle and it measures 90 degrees. Now, in a right triangle, what you have making up that 90 degree are called legs. So you have two legs. You have two legs, and a right triangle has two legs, and the two legs make up the 90-degree angle. So we have leg A, and we have leg B. All right, so you have leg A and leg B, and it really doesn't matter which side, which leg you call A and which one you call B, okay? They can be interchanged, all right? So you could have called this one leg A and this one leg B. It doesn't matter, all right? But what does matter is across from that 90-degree angle, okay? So you have a 90-degree angle. Across from it is called the hypotenuse, all right? Your hypotenuse. Now your hypotenuse, this is always C, all right? Your hypotenuse is the longest side of your right triangle, okay? And it's always across from that 90-degree angle. Never makes up the 90-degree angle. It's always across from. It's that third side, okay? It's the not leg, the hypotenuse, always the C. All right, so we have some blanks here, and we're going to fill them in, all right? And those blanks are kind of small, and you know I like to write kind of big, so I'm going to write outside of the box and draw an arrow to the box that it belongs to. Okay, so we are talking about right, okay, because they all have right angles, and this only applies to right triangles, okay, only right triangles. So a right triangle is a triangle with one right angle, okay, hence the name right triangle. The legs, okay, leg A and B, are the sides which form the right angle. Okay, so you have your right angle and legs A and B. Then you have your hypotenuse. The hypotenuse is the side opposite the right angle. It is the longest side of the triangle, and it's also always C. It's always your C. All right. So we have leg A and B, and we have C. Okay? Now let's check it out. The Pythagorean Theorem, okay? Pythagoras is a really old, dead, ancient guy. You can go look him up. And he had this theorem. All right? It's a pretty good theorem. So we still use it today. And what it says is a squared plus b squared. So you take leg A and square it, you take leg B and square it. And if you add those two totals together, that equals c squared. Now what we want to remember is that when you square something, you aren't multiplying it by 2. What it is, a squared is a times a. And b squared would be b times b, and c squared would be c times c. All right? So that's another thing you need to remember. This goes back to, I think it was Unit 1 or Unit 2, the very beginning of the year, when we were using our exponent rules. Okay, so a squared would be a times a. All right, and we have our model here. So again, we have our 90-degree angle. You always find your 90-degree angle, find the thing that looks like a right angle. Okay, that's 90. Okay. Then you have leg A, you have leg B, and you have your hypotenuse C. The hypotenuse is always C. All right. So today what we're going to focus on is actually finding the missing hypotenuse. All right. And you need to remember one more thing, okay, before we move on the back in practice, okay? So what you need to remember are your opposites in math, okay? So opposite signs in math undo each other. And we've been using opposite signs in math for a while. When we do our equations, I always ask you what's the opposite of addition, and you'll tell me subtraction, and we will subtract on both sides to mathematically move a number, all right, or a term. So the opposite signs that you need for this equation, okay? Well, we have squaring. We have to find the opposite of squaring, all right? So opposite signs, because they undo each other, okay? So the opposite of squaring, okay, the opposite of square, so like x squared, okay, x squared. The opposite of squaring is the square root of. So the opposite of squaring is square rooting. And square rooting looks like this. All right. So this is your radical symbol. Okay. Squaring and square rooting are opposite signs, so they undo each other. Now remember, okay, we haven't seen that symbol in a little while. Okay. So this is your radical symbol. Okay. A lot of people mistake it for division. It is not. All right. This is the radical symbol. And in my classroom, my large calculators do not have the radical symbol. I did have an entire class set that all had the radical symbol, but I have had some students destroy my calculators this year. And so therefore we don't have a complete class set. So if you have a calculator and you need help using your radical symbol, because sometimes it's a 2-button function on some calculators, let me know. I can help you. Or my smaller calculators all have the radical symbol on there, because you're going to need to know how to locate it and how to use it for the calculator you're using, okay? So the radical symbol is going to be very important, because it means taking the square root of whatever's inside. And you need to take the square root of, because that is the opposite of squaring. Now let's see what we're talking about on the back. All right, on the back are 2 real-world examples that they really like to use. The first one is the leaning ladder, okay? You lean a ladder against a building. Okay, here's our ladder. It's leaning against a house, all right? And what that forms is a right triangle, okay? One leg is the building, one leg is the ground, and then the ladder makes up the hypotenuse, all right? So we always look for our little right angle, because we know that our right angle is that 90-degree angle. And then we have the legs that make that up, okay? So we have leg A, and we have leg B. And remember, it does not matter which one you call leg A or which one you call leg B. I just always start with the smaller of the legs, if I can tell, okay, and call it A. And then I call the other one B. Just because, you know, I like to be consistent all the way through with my math. And then what we don't know and what we're looking for is our hypotenuse, which is C, and that is the length of the ladder. So one of the ways you can use this is to know how long of a ladder you need to reach your roof, okay? Always being asked, oh, when will I use this in real life? Here's a real-world example. All right. So we have our Pythagorean Theorem, which is a squared plus b squared equals c squared. Okay, that's our Pythagorean Theorem. So let's fill in what we know. Well, we know a, okay, is 5, so 5 squared. We know b is 12. plus 12 squared. And what we don't know is c. That's what we're looking for. So c squared. All right, now remember from the front, a squared plus b squared equals c squared. A squared is a times a, b squared is b times b, and c squared is c times c. Okay? So, 5 squared. That'd be 5 times 5, so 5 squared is 25. 12 squared is 12 times 12. 12 times 12 is 144. And we are looking for c squared, or x. Okay, if you wanted to use the x, doesn't matter. All right, so we are going to add together the 25 and the 144, and 25 and 144 is 169. So you now have 169 equals c squared. All right, so remember on the front, I told you that the opposite of squaring something is to take the square root of. Okay, so we don't want c squared, we want c. We want c by itself. So what we're going to do is we're going to take the square root of both sides, because remember, what you do to one side, you got to do the other. So we're going to take the square root of 169. We're going to take the square root of c squared. Squaring and square rooting cancel each other out, and you're left with c over here on the right. Now you use your handy dandy calculator, and if you use one of mine in class, what you do is you take 169, you find your radical button, you hit your radical button, and it will tell you that the square root of 169 is 13. So the length of your ladder is 13 feet. Okay. Now this is called a Pythagorean triple because all three sides are whole numbers. Okay. Not all triangles are like this. Not all right triangles are like this. Not all right triangles will give you a Pythagorean triple, but this is one of them where you have no decimals on any side. Now, it's a lot of times you will have decimals, though, okay? And this next example is an example of that. All right, here is another example that they like to use, a flagpole in the ground. So it says a 12-foot flagpole is placed in the center of the square area. To stabilize the pole, a wire will be stretched from the top of the pole to each corner of the square. Flagpole is 7 feet from each corner of the square. All right, and they drew you a picture. All right, so and of course our copiers aren't very good. So the flag is 7 feet from the corner. All right, 7 feet from the corner. Then you have your flagpole. So we want to stabilize these flags. So we got to know how far out, but we want to keep it upright. How far out we put our wire to stabilize it. Okay, so this is what we're looking for here. This, in my classroom, if it looks like a right triangle, it is a right triangle. So we have a right triangle right here. Okay. If it looks like a right angle in my class, chances are it is. Okay. So this is a right triangle. We know the right triangle, that's a 90-degree angle. Okay, and we also know that making up that right triangle are its two legs. So we have a 7-foot leg, we'll call this A, and we have a 12-foot leg, we will call this B. And what we are looking for is C, the length of the wire from the top to the corner of the square. We need to know how long that wire is. Remember, a squared plus b squared equals c squared. So let's see. We have a squared plus b squared equals c squared. All right. So let's fill in what we know. We know a is 7 feet. So 7 squared. We also know b is 12. 12 squared. What we are looking for is C. Okay? We don't know the length of that wire. So again, remember, when you are squaring something, so a squared is a times a. So 7 squared is 7 times 7, so 7 squared is 49. 12 squared is 12 times 12, so 12 squared is 144. And we are looking for c squared. So we add these together. 49 plus 144 is 193. And that equals c squared. Well, that's great, except for we don't want c squared. We want c by itself. So we are going to take the square root of both sides, because that is the opposite of squaring something. Squaring and square rooting cancel each other out, and you are left with c on the right side. Now let's see the side. All right, the square root of 193. So if you're using one of my calculators, you put 193 in, you put in the radical sign, and it is 13.89. Okay. Now it says, what is the length of the wire round to the nearest tenth? Well, the nearest tenth, okay, that's 1 unit to the right of the decimal, and you round it based on its next door neighbor, which is a 9, so that's above 5, you round up, so that would be 13.9 is the approximate length of C. So we do that if rounding is your strength. If rounding is not your strength, if you're like, I'm kind of iffy on it, then what you're going to do is you're going to write whatever's in front of the decimal, you're going to write the decimal, and you're going to write the 2 digits to the right. And stop writing, because you may have a string for some of these, and the entire screen of your calculator is filled. Just write the 2 digits to the right. Okay, 2 digits to the right. And if rounding is your thing, please round. Okay, to the nearest tenth. Rounding's not your thing. Rounding is not one of my 8th grade standards, so if you're rounding, cool. If you're not rounding, I'm okay with that too. Just give me the 2 digits to the right.